Okay, here we are, kiddos. This is the Unit 7 review, so we should be done with entire of Unit 7. Now, Unit 7 is obviously a really large unit, and so this review is actually pretty large itself. So with that being said, what I'm going to do to kind of cut down the time of this is I am going to do competencies 1, 2, and 3 on this video, and then I'm going to make another video for competencies 4 and 5. So that will kind of cut down the time a little bit. So if you're only interested in competencies 4 and 5, go ahead to the second video that should be posted. However, I am going to get started right here, right now, with the first 3 competencies. With these 3 competencies, we have a competency on the empirical rule. We have just in essence z-scores to x's, x's to z-scores with a little bit of area. And here we have pretty much understanding how to use the z-table. Now, mentioning the z-table, actually I should say it this way. Mentioning the empirical rule. The empirical rule will only be used on competency 1. So don't use your z-table when it comes to competency 1. Only use the empirical rule. Don't use the z-table. From competencies 2 on out, absolutely use your z-table. But Unit 1 is empirical rule only. Okay, so with that being said, let's go ahead and get started with this. Again, I'm only doing competencies 1 through 3 in this video. Question 1. Create a normal distribution. What a normal distribution is a curve that bows up in the middle and gets lower as you get to the sides. It doesn't curl back up. It doesn't lean to one side. It's straight up like that. So that is what a normal distribution is. Okay, on with the empirical rule. According to the empirical rule for standard deviation that is symmetrical and bell-shaped, approximately blank percent of the data lies within 2 standard deviations on each side of the mean. So here is our empirical rule. Here is our mean. Here's the average. So we go standard deviations up, and we go standard deviations down. And so if this is the mean right smack dab in the middle, let me change colors here. Right smack dab in the middle, to be within 2 standard deviations, that means we go up 2 standard deviations, but that also means that we go down 2 standard deviations. So to be within 2 standard deviations on each side, that would involve these 4 sections of the curve. And so knowing the empirical rule, this is 13.5, 34, 34, and this one over here is 13.5 as well. So what percentage lies within that range? Well, that'd be 13.5, 34, 34, and 13.5. And this adds up to be, I believe, 95. So 95% of the data falls within 2 standard deviations of the mean. Here we are using the empirical rule to figure some stuff out. Here it gives an average life expectancy of 600 hours with a standard deviation of 100 hours. So again, the average goes in the middle, and then we go up standard deviations, and we also go down standard deviations. So what that means is the average in this case is 600. Standard deviation being 100, so that would be 700, 800, and 900 on those lines, as well as 500, 400, and 300. They want to know what percentage is between 600 and 700. So it'd be just the singular bar right there. That's between 600 and 700. That singular bar just so happens to be 34% of the data. So this is just straight up 34%. Here we are asked about two probability distributions. This one wants the larger standard deviation. The standard deviation is a general width. So this wants the larger width. So the larger width, the larger standard deviation would be A. And then number 5, a farmer notices wheat production mean, his average, is 35 bushels per acre with a standard deviation of 8 bushels per acre. So again, the average goes in the middle, we go up, standard deviations, 1, 2, 3, go down, standard deviations, 1, 2, 3. So what those specific numbers are in this case is this, the average is 35. So if a standard deviation is 8, this would put us up to 43, 51, and 59. Going down standard deviations, this would put us down to 27, 19, and 11. This particular problem wants to know the probability, the area between 19 and 35. So 19 all the way up to 35 would involve this bar, and it would also involve this bar. Knowing the empirical rule, the one to the left is 13.5, and the one more in the middle is 34. So in this situation, it would be the combination of 13.5 and 34, which is going to be 47.5%. So that is the empirical rule with competency 1. If you need more information or if you need a reminder of what the empirical rule is, take a look at video assignment 7A. Okay, moving on to competency 2. This is one where we are dealing with some formulas, so Z formulas and the X formula. So here it says the class average is 74% with a standard deviation of 5%. Aaron earned 82%. What is the Z score in this situation? So the question is asking, what is Z? So Z comes with a formula that is x minus mu divided by sigma. So plugging in the numbers where appropriate, that would be 82 minus 74 divided by 5. So the Z score in this situation is 1.6. Second question is pretty much the same thing. However, they'll give you some different information. All right, so here we go. The average is 74. The standard deviation is 5. Sally's Z score in this situation is negative 2.3. They want to know what is Sally's percentage. That is the X. X is the whatever the story is talking about. In this case, it's percentages on the text. And so this is asking for the X. So X is equal to Z sigma plus mu. So the X in this situation is going to be negative 2.3. Sigma is 5. And mu is 74. Sally earned a miserable 62.5%. Okay. Here we are dealing with a combination problem. So this kind of deals with, are they fired or okay? So they give the stipulation. So it says a pizza franchise specifies to have an average of 8 ounces of cheese per pizza with a standard deviation of 0.5 ounces. A difference of more than 3 standard deviations means they're in trouble. This is in essence a Z-score. A Z-score is the number of standard deviations away from the average. So that's what that is saying. Okay, we'll get into that in here in just a little bit. Here in question A, it says a pizza was found with 6.9 ounces. Okay, what I'm going to do is I'm going to find the Z-score, and I'm going to compare it with this allowable 3 standard deviations. All right, so here we go, the Z-score. The Z-score in this situation is x minus mu divided by sigma. So that's going to be the 6.9 minus mu divided by sigma. Oh, sorry. All over again. Here we go. 6.9 minus 8 divided by sigma, which is 0.5. So in this situation, the z-score comes out to be negative 2.4. Now, what does that mean? Is this business in quote-unquote trouble, or is this business okay? So here's what that allowable 3 standard deviations that is specified up above here means. It means this. Here's a franchise or a company in general. What they say is if you are 3 standard deviations above or 3 standard deviations below. Again, standard deviations above or below the average is the definition of a z-score. So if you're above 3 standard deviations, below 3 standard deviations, that means you're in quote-unquote trouble. So if you're in this red area here, that means you're in trouble. However, if you're in between, that implies that you're okay. All right. So where does this this pizza franchise fall? This has a z-score of negative 2.4. So where it is substantially negative, it's not quite negative enough to get in trouble. All right, so negative 2.4 is still in the okay range. So make sure you specify that and you answer the question that's being asked. Okay, and the next question, they want to know what is the minimum amount of cheese. So the average is still 8, and the standard deviation is 0.5. All right, so the minimum amount of cheese would, the minimum amount, the smallest amount, would exist right here, okay, which has a z of negative 3. If they wanted the maximum amount of cheese, that would imply that the z would be a positive 3. So here we know that the minimum amount of cheese is at the lowest acceptable level, which is 3 standard deviations below the average, or whatever the number in the problem specifies. All right, so this is the minimum amount. Again, that would be negative 3. If it's the maximum amount, it would be a positive 3 for this. So here we go. So this x is z sigma plus mu. So in this situation, negative 3 sigma plus mu. So the minimum amount of acceptable cheese on a pizza is 6.5 ounces. All right, now we are introduced to how to use a z-table. So make sure you have your z-table handy. So in this problem, we are dealing purely with z, so I'll just start in with that. And we have a z of negative 2.13 and positive 1.67. And so what we're asked to do is, okay, so negative 2.13 and positive 1.67. And what we're asked to find is what is the area in between those two things. So what we do is we find the area of each, and then we'll take the big area minus the small area. So I'll find these areas. So the area of negative 2.13, for instance. So this will require a z-table, negative 2.13. So negative 2.13 is 0.166. I totally wrote that wrong. Sorry about that. And I also need to find the area of the 1.67. So 1.67. Okay, now that I have those two figured out, to find the area in between those two, what I need to do is take the big area minus the small area. So in this situation, the area that I want is going to be the big area minus the smaller area. And that's how you find the area in between something. Okay, last but not least is this area under standard normal curve between the mean and a z of 1.67. So this should actually be incredibly easy. As long as you know what the mean means. So the mean comes smack dab in the middle. And so if something comes smack dab in the middle, that means it is 0 standard deviations away from the self. Okay, it has a z-score of 0. Also, the area to the left, if the entire curve is 100% or 1, okay, if the area underneath an entire curve is 1, and you are now chopping it in half and looking at the area to the left of it, this area to the left would obviously be 0.5. And so we know all of these things about the mean right now. So the area to the left, if I were to look it up on the table, it would be 0.5. Now I just got done using a z-score of 1.67 in the previous problem, so I know the area to the left of that is 9525. If you don't know what it is, look it up. Okay, so if I need to find the area between these two things, all I need to do is take the big area minus the little area, which in this case is 0.5. All right, the last part of this video is competency 3. And this is just a lot of problems understanding how to use the z-table and understanding the art of moving between an axis and an area and vice versa. Oh, sorry. If you need more help with competency 2, take a look at assignment 7C. 7C is where competency 2 is really kind of touched off on. Competency 3. So these are similar to the problems that we just got done doing. However, they start at an X and not a Z. So here we have X's, if this average is 10, we have an X at 11, and we also have an X at 14. So I am interested in finding the area in between those two. So again, we have an X of 11 and 14. So I need to find the areas of both of these, and then I'll take the big area minus the little area. However, the roadblock in between now and then is I have to go through the z-score to get that area. Okay, so let's go ahead and start to work. I am going to find the z-score of 11. Okay, and then I look that up. So this one is 0.50. So 0.50. I have to do that same process with 14. Look that up. This one is 2 or 2.00. kind of minimize some of the stuff so I can distinguish some of my work from my other work. Now to find the area in between those two, what I have to do is I have to take the big area minus the small area. Okay. And then we get into warranties and things like that. Warranties are typically areas to the left. So here we go. Have an average of 2.7, standard deviation 0.4. And in this situation, we have a 2-year warranty. So the warranty is going to be covering anything that doesn't make it up to 2 years. So 2 years is the X in this situation. I am looking for the area to the left, so let's go ahead and find that area. So I'm looking up negative 1.75. So negative 1.75 is the 0401. That's the area to the left of that. That's exactly what I want. So that is my answer. Okay, here is a problem that we're going to have to reverse engineer the concept because they're going to start us off with an area and we need to bring it back to the X. Okay, so here we have a situation in which they're covering 15% of of their product. And so a percentage, a probability is an area. So how they're starting us in this problem is they are giving us an area of 15%. What is the X? What is the number of years that produces that 15%? So we need to go backwards in this operation. So if we usually go X, Z area, this has to go area, Z, X. So I know the area, so I need to turn this first into a Z. And again, this is not an X. So we're not running it through X minus mu divided by sigma kind of idea. This is, I'm using the table and I'm looking for the Z-score that is associated with 0.1500. Okay, so I'm looking for 0.1500 so I can get the Z-score. So 0.1500 would occur right in there. I notice that 1515 is in essence 15 over, and 1492 is 8 under. So that implies that the 1492 is closer. So the 1492 is the 15% that in essence they're saying. So that's going to occur at negative 1.04. It's going to occur at negative 1.04. So that is the Z-score. So I just took one major step in the correct direction. Now, ultimately, I'm asked what is the number of years that would be this warranty period. So the X is Z sigma plus mu. So in this situation, the Z that I just found is 1.04. The sigma is 0.4 years, and the mu is 2.7. So the X in this situation is the answer that I'm after. that is going to be 2.284 years. So what would the warranty period length have to be? It would have to be 2.284 years, and that would cover 15% of the product. Okay, number 13 is our trick question. So in this situation, they want to know what is a z less than 0. So the question is ultimately asking, what is a z that is less than 0? So a z that is less than 0, z is going to be the answer. Okay, and they want 30% to fall between the z and 0. And that's the trick right here. Because when I use my table, when I look at this table, all of these are areas to the left. So no matter what I look up, it's always going to give me an area to the left. So if this is going to be 30% to the middle, what would be the area to the left? Okay, so again, what you kind of have to understand is that a complete curve is 100%. That means the area from the middle over is 50%. So if you want this chunk to be 30, that implies the area to the left would have to be 20. That's the concept here. So I'm not so much interested in the middle of being 30%. Yes, that's what I need to obtain, obviously. But I'm going to be looking up 20%, because that would be the area to the left of this line. This line, the area to the left would be 20%. And the question is asking, well, what is that z-score in that scenario? So the z-score of an area of 20%, to get that middle to be 30%, 20% is going to be right here. This one is 5 over. This is 23 under. The 5 is obviously closer. So this is my 20%. That exists at negative 0.84. That exists at negative 0.84. And notice that the question was asking, what is the z less than 0? So that is the end of the ballgame. Don't try to turn it into an x or something. Yeah, that is the answer. The z is equal to negative 0.84. All right. Now the last problem in this in this chunk is a problem in which you really have to pay attention to the labels of what your information is saying. All right, so here it says an average is 28 months, standard deviation of 5 months, and we will replace watches up to 2 years. So there's the weirdo right there. So again, the easiest way to get this thing rolling is to turn the larger type of unit into a smaller type of unit. So like turn like hours into minutes, days into hours, that sort of thing. In this situation, that's going to be turning years into months. So there's 12 years, or it's 12 months in every year. So this would be 24 months. So that is what they will replace. They will replace things up to 24 months. That's AKA 2 years. So what percentage are they expecting to replace? So let's draw our picture. So they'll replace everything up till there. So they'll replace all of this, and that just so happens to be 24 months. So let's figure out what percentage that is. What is the area to the left? So the first thing that I do is I turn that into a z-score. And then the area associated with that to the left of 0.8 which is 0.80, negative 0.80. So we got negative 0.80 is the 2119. That is the area to the left. That is exactly what I want. That is the answer to the question. Okay, so this is competencies 1 through 3. Again, I will tackle competencies 4 and 5 in the next video. So stand by on that. That is it.